Now we want to see how ADP changes with respect to time. In order to do that, we're going to select Make Window, Create. This opens a new window that it's right here, is located here. Observed the white square on the window. This indicates the current window. This is the current window, the one that has the white square. If I click on the original window, like here, the white square appears here. Therefore, all the menu options apply to this window because this is the current window. So what we want to do right now is take this window, which is in this moment ATP versus ADP, and we're going to change the axis information. We're going to show in the x-axis the variable t, and on the y-axis the variable ADP. Going to select OK, and here we observe that ATP reaches an asymptotic value of 0.73 and ADP reaches an asymptotic value of 0. Now we're going to create a window for the faceplane. We're going to do this with a Make Window. We're going to create a new window. This new window is created as the previous window we have created, which is ADP versus time. What we want to do right now is to view the axis for this particular window. We want to see the 2D information, and we're going to change the x-axis to be ADP and the y-axis is going to be ATP. I'm going to set the labels, or we can do it on the opposite way as it's indicated on the lab, ADP, and the labels will be very useful. We're going to set ATP for the X label and ADP for the Y label. Now observe what will happen if I click OK. We have a new window. This window is ADP versus ATP. I can go to the menu and select the null lines, and the null lines will be drawn here. Well, you might think that nothing happens, but if you observe carefully, there is a green line and an orange line right here next to the axis. We don't see anything because the scale is not appropriate for this plot. Many times it is a matter of trial and error to find the correct scale for the plot. But we're going to set it correctly right now. And that scale is going to be from 0 as the minimum x value to a minimum x value of 2. We're going to apply the same minimum to y. So y and x go from 0 to 2. That is, ATP and ADP are going to vary between these two values. I'm going to hit OK. And now we observe the null lines as we had wanted to draw them. Okay, these are the null lines for this system. Now you know that in the cross of the null lines we have equilibrium. Let's find some trajectories in this plot. To do the trajectories, we go to the menu Initial Conditions, and then we can select Mouse. We see this dialog telling us, yo, click on Initial Data. That's exactly what we're going to do. We're going to select one point here. That is going to be our initial data. and you see that a trajectory is drawn. The trajectory comes very close to the axis, so it's hard to see what is going on, but actually it's trying to reach the equilibrium point. Now we can go and draw more trajectories. To do this, we don't have to go back to the menu, we just have to hit the keys I and then M. We see the message, click on initial data, and then we can do this several times. This will give you a good indication of what the system is doing. Next, we're going to find equilibria, stable and unstable. To do this, we're going to click on singular points, and then we're going to select the mouse option. Once we do that, we see this message, click on guess. So we're going to click where we expect an equilibrium to exist. We know it's going to be in the cross of the two null planes, so let's select this point. It's going to ask us, do you want to print the eigenvalues? Select yes. It's going to ask you, do you want to draw the strong sets? Select no. And then this window called equilibria is shown. This window has several values, C plus, C minus, IM, R plus, R minus. This means R plus equals 0 indicates that there are 0 eigenvalues that are purely real numbers and that are positive. And R minus equals 2 indicates that we have 2 eigenvalues that are real numbers and both of them are less than 0. We can see these values by going back to the command window. In the command window, the eigenvalues are printed. So as you can see, we have one negative value here with a 0 imaginary part and a negative value here with a 0 imaginary part. This indicates that the two equilibria that we have are stable points. And one question that we could ask is this a spiral? Because it looks like it's kind of spiraling, or is it just a regular stable node? Well, the answer is, look at the eigenvalues. Since we have a 0 imaginary part, then we know it's not a spiral.